Jeremy, will you watch the new admittees? I'm going to get started.
Sure. All right.
Okay. Let me close this out.
I'm gonna start.
Welcome, everybody. Delighted to have everybody here to our September meeting. Um, I'm going to ask you when our guest speaker speaks, that you all mute yourselves and possibly even shut off your video. That way, the throughput's better. Um, you can even do that when I'm speaking if you feel like it, but you don't have to. You might want to shut off my video. I don't think you can do that, but let me share my screen, and we'll actually, before we do that, I think what we'll do is we'll go to our report. Lou isn't here, so maybe I'll go first, and then we'll go to our reports. So let me open this up and slideshow from beginning, and then let me share. And from beginning. So one of the things that bothered me today, I've been inside most of the day working, and it's nice, air conditioned, cool. It's really lovely. I go outside and it's hot. It hits you in the face. But the news has already told me that it's the end of summer. Well, how can it be the end of summer and not the beginning of something else? It sure hell isn't the beginning of fall. And the beginning of fall really isn't until the equinox. So I thought I'd talk a little bit about the equinox, the actual official equinox. And this is a very basic level. I mean, we all know the equinox is when the summer begins. This is the equinox. Actually, that's a Chevy Equinox. That I don't know how that got in here. That doesn't belong there. It really all stems from the fact that the Earth is seriously screwed up. We know that, fires in California, a pandemic everywhere. The Earth has to be completely screwed up, and it's out of kilter. And when we were in elementary school, liberal arts grads who thought that a graduated cylinder was a very smart round person taught us and showed us pictures like this. So as a result, for years and years and years, they said, "Oh, this is what the Earth looks like, but it wobbles." So I'm thinking the end of a top wobbling, and I'm thinking that, well, the northern hemisphere tilts towards the sun during the summer months, and then the southern hemisphere tilts towards the sun during its summer months. Well, I mean, you understand. Well, that's not right, though. It's more like this, 23 and a half degrees off center. And as we rotate around, um, the angle is different. And we know that. And there are a lot of myths about what the equinox is. And I really enjoyed looking at what they are. And I thought I'd bring some of them to your attention. One of them is that you can balance an egg on its end at the moment of the equinox, because the gravitational pull of the Earth and the gravitational pull of the sun are roughly equivalent. Of course, this is balderdash. I'm going to show you how to balance an egg on its end. I have a visual thing here. You take the egg, you chop off the end, and you don't have any problem balancing it on its end. Absolutely no problem whatsoever. Of course, it has to be a hard-boiled egg, and it has to be peeled, but it works like a charm, and it has nothing whatsoever to do with the equinox. The fact of the matter is, you can balance an egg on its end if you try hard enough any time of the year, and it has to be the right kind of egg. Another myth is that the shadow disappears at noon. I love this photo because it purports, this is classic Photoshop. It purports to show that the level has no shadow, but if you look further back in the photograph, there's a shadow there. What's casting the shadow? I have no idea. The only way there's no shadow is if you're standing on the equator at the precise moment of the equinox, directly under the sun. A lot of people say, "Oh, it's the equinox. Day and night are 12 hours long. That's why it's called equinox." Well, the fact of the matter is, the equinox is the moment at which the sun passes over the equator. Blink and you miss it. So let's talk about some real facts about the equinox. Mayan astronomers mark the equinox. They were very aware of it. Modern days, we don't really celebrate first day of fall, first day of spring that much, but at Chichen Itza on the Yucatan Peninsula, the pyramid of Kukulkan, also known as El Castillo, has 365 steps. I would zoom in so you could, and we could watch this for a while and you could take the time to count, but take my word for it. And on the fall and spring equinoxes, a shadow appears on the pyramid surface that looks like a serpent descending the steps. That's pretty cool. And then, of course, years ago, my relatives helped build these buildings in Egypt. And some researchers have shown that the orientation of the pyramid of Khafre and the red pyramid at Dashur are very closely exact to aligned with where the equinox is. And actually, there's a peer-reviewed piece about this, and the guy was able to sort of reset it up in his own backyard using rods and stuff. And if you account for the precession of the Earth, the pyramids are exactly right on to what would be exactly when the equinox is. In Japan, they use the equinox to actually visit the graves of ancestors. It's sort of a tradition that they do to celebrate the fall, to celebrate the harvest, and so forth. Of course, if we were waiting for the equinox on Uranus, we'd only see it every 42 years because Uranus is on an angle at 98 degrees, so it's lying on its sun. So at least we get 2 a year. Waiting for one on Uranus would take a long, long time. The main thing that the equinox means is more darkness, just like Lou was saying earlier. So go on out there and observe when there aren't clouds. And I want to note two more things. One is September 26th is International Observe the Moon Night. And there's all kinds of programs about that. It'll probably be cloudy in Philly. And I also want to thank Prasad Agrahar, who posted on our listserv earlier today for those cloudy nights. And this is a shorter version of the link that Prasad posted. This is the Royal Observatory of Greenwich's awards for astrophotography for the year. And there is a spectacular photograph of Andromeda that it feels like you could just reach out and touch it. There's a lot of great photographs on that site. So next cloudy night, go take a look at that site. And otherwise, have a happy fall. Let's stop sharing. And Lewis is here. So I'm going to throw it now to our committee reports, and we'll start with Brian. Unmute yourself, Brian.
Sorry. We have 6 new members this month.
Yes.
Jesse Cohen, Amanda Gattuso, pardon me if I get your name wrong, Stanley and Betsy Williams, Michael Simonak, and Shruti Ratan. And everyone hails from PA except for Shruti, who comes from Newark, Delaware, all the way from Newark, Delaware. That's all I've got.
Thank you.
Lots of clapping.
Closer to the equator.
Right.
All right. Lewis, you're up.
Sure. I have a few things to talk to right now, and they're mostly just heads up thing. It came up again today about our dues. We are on an annualized dues program that is, basically your dues, no matter where you pay them, are pegged to the end of the year, and that's just the way it is. So it works for a full year. But I wanted to remind you guys that this December is another opportunity to rejoin DVAA, and you'll be seeing more and more about that stuff. Also, I just want to remind everyone that we have a rental program going on. I've recently rented the 5-inch Celestron twice, and we have more scopes. Go look on our observing page on rental observing page on the website to find out what's around. And we'd love to have you use the club scope. So thank you very much.
Thanks. Thanks very much. I'm looking to see if Nate is on, and he's not. So, Janet.
Okay, so I'm Jan Rash. I'm speaking tonight on behalf of Andrew Hitchner, our observing chair, because he's away tonight, next 2 weeks, to tell you about the Valley Forge Star Parties, which are restarting this month. So we're cleared. Valley Forge has cleared us to go to have our Star Party on the 26th, and we'll be doing it according to a format that's similar to what we did for a couple of recent outreach events. So there'll be, people will be asked to bring their own chairs, and they'll set up on the field with their chairs, their own binoculars. And the entertainment will be several different stations that will be held on different topics. And then followed by, when it gets dark enough, a laser tour by Andrew of the major constellations, bright stars, and planets. And what we did for the first time last month, which worked out great, was that Gary and Wayne do a live telescope and camera view of the sky and project it on a big screen. And so we're going to do that again. And that way that we relay back and forth between what Andrew's pointing to and speaking about, and then what's seen on the big screen. So all while helping people to learn the sky and to learn to use their binoculars. So the good thing is that we don't have a really strong, we have a cap, an AT&T cap, but I don't think it will be a problem. And so if anyone would like to come out on the 26th and see what it's about, just come out and hang out with everyone. We will not be too full. There will be room for anyone who wants to come. I do ask that you register so that we can reach everyone if there's a weather change. And you can do that on the website. And that way we'll be able to keep an eye on the total attendees, because we do want to keep it manageable, but based on the way things are going, I think we'll be absolutely fine with any members that want to come out. So hope to see some of you on the 26th. You don't need to bring any gear, just bring some binoculars if you want to, because we can't share telescopes with COVID restrictions. Any questions?
Yeah, actually, one quick comment, Jen. If people do come out, green laser pointers would be welcome, because they don't show up real well. So, and I know a lot of the club members have them. So the more we can use multiple green lasers to point at an object, the better. People have a chance of seeing them.
With that in mind, Louis Berman, could we borrow yours? Yours is like a lightsaber.
Absolutely. I actually have 2 or 3. I know where 2 are, but I actually own 3.
Well, yeah, bring the keys too to start them. And
you know, they're old fashioned, you know, you just pull on the starter cord, you know,
oh, okay.
you know, let rip, it turns over, it goes real well. Jeremy showed us how to do it. Very good.
I have visions of our insurance company canceling our policy.
Yes, yes.
Janet, did you want to talk about the auction?
Okay. Yeah, I was hoping we could also talk about it, just some details after the meeting to see if anybody has any further ideas. But Jeremy had the idea about a month and a half ago, maybe, to do it on an online auction, because we feel like it still would be difficult to do an in-person auction. So checking into some options, we located one way to a web way to do it that is cheap, and we can make it accessible to all kinds of make it widely accessible to non-members, which is what we thought we wanted to do to make it a a fun thing, a fun event. So it'll be advertised on Facebook. We'll let other clubs know about it, and everybody will sign into this website. And then what we can do is handle the payments exactly through Club Express, so not pay PayPal or anybody any commission. And it's very cheap, $70. Just takes a little time to set up, and so that's the plan. And if anybody has any comments or some ideas about how to do it better, let's talk about it after the meeting, and maybe we can gather everyone's thoughts.
Thank you. Also, any donations will be accepted.
Oh yes, always accepting donations. If you have any donations, all you need to do is send me a picture and a quick description.
Yep.
And put it on the website.
And just one quick thing, the board needs to meet to look at our existing inventory, because you'll remember we have things that were old scopes that we intended to auction, but we want to make sure that we are all in agreement what we're going to
Yeah.
offer up.
We will take care of that. Very good. Well, now comes for me, at least, the highlight of the meeting. I am very excited to have Janie Radebaugh here. I have to thank my son for helping set this up. He, as I may have mentioned last month, he, Laura and Janie went to Iran in a pre-Trump world. And I don't know why my son was obsessed with going to Iran. He's a musician, for crying out loud. He plays stringed instruments and plays in Broadway shows in New York. Janie, you probably have a better idea what he was doing there than I do. But I'm very excited to have a scientist of Janie's caliber with us tonight. And I'm going to let Jeremy do the former introduction, and I'm going to sit back and enjoy. So Janie, welcome. Jeremy, the floor is yours.
All right. Thanks a lot, Harold. So as you can tell, we're taking advantage of COVID and these online meetings, and we're getting some speakers from outside our local area. So it's giving us an opportunity to really broaden our horizons, both astronomically and geographically. So we're really honored tonight to have Janie Radebaugh with us. So just to give a preview of next month, we're going to have Dale Gary from the New Jersey Institute of Technology, a little more local, but a little bit further away. And he's going to be talking about the anatomy of a solar flare. So he works a lot with solar research with the Big Bear and the Owens Valley Radio Array out in California. So he'll be telling us about some of the work he's been doing on solar physics. So tonight, as mentioned, we have Dr. Janie Radebaugh, who is a planetary scientist and a professor of geology at Brigham Young University in Utah. So she specializes in Titan, Io, the moon, Mars, Pluto, and possibly a few other objects as well. And as Harold said, she's also done a lot of traveling around the Earth to find sites that look a lot like these other planets. So Janie got her start at BYU doing her bachelor's in physics there and a PhD in planetary science at the University of Arizona. So she's been involved in a number of space missions, including Cassini, as well as the upcoming Dragonfly mission, which will put a helicopter on Titan, which sounds really, really cool. And she has been frequently featured on television programs and other areas in the media as an expert, I was going to say expert witness, but that sounds a little too legal, as an expert commentator. So tonight, she's going to talk to us about the windy planets. So please join me in welcoming Janie. And just remember, turn off your mics and please shut off your cameras during the presentation. All right.
Thank you so much, Jeremy, for having me, and Harold for thinking of inviting me. It's just, I'm really honored to be here, and I love to see the size of your group and how active you are and everything. So, so far away from me, I'm way over here in Utah. So, so you see a little bit of light still. We've got a little daylight left. And I'm a little sad you can't see my Cassini t-shirt. Here we go. It's the end of mission, which was 2017. So a few years now. I'm really kind of amazed that it's been that long. And so I'm just gonna share my screen here. I think you have to give me permission to be able to share, if that's okay. And I will put up a.
Are you not able to share?
I think it said, oh, now I am. Yeah. Okay. All right. So does everybody see a single slide that says the windy planets. Is that
Yeah,
there?
you're good to go.
Okay, awesome. I'll try to watch things in the chat window too, if anybody has anything. And then also I'll just have some time after for questions people would like. So I've started to realize that I have been kind of honing in on studying wind, which is really interesting. We're always annoyed by wind, I guess. It can get in the way of things. I just got married 3 weeks ago. My first time, and I decided to get married on a sand dune. I should show a picture of that. They're really pretty pictures. Maybe at the very end I'll pull some up. But it was kind of amazing because everybody said, well, I mean, it's their sand dunes. Isn't there going to be wind? And I said, yeah, that's the best part of it. And it turns out there was a big windstorm that came up and it kind of scattered everybody down the hill. But a few of us stayed up there and it was just really beautiful. It kicked a bunch of dust up into the air, made some very beautiful pictures. And so I thought that was special. Actually, I'm just going to do that right now while I'm thinking about it. So now I'm going to stop share, possibly. I teach with Zoom 2 days a week, but I'm still trying to get used to it. It's amazing. Let me just go find the picture really fast that I think was lovely. You know, I mean, so sort of out of chaos can come beauty, and that's kind of what happened here because of that big wind. Of course, everybody looked at me and said, "Is this going to continue?" And I said, "Probably." So everybody just left, but of course, the photographer had to stick around, and so what we ended up getting. Let me share this really quick. Was this really beautiful scene? There's no filter or anything. I mean, it just ended up being so pretty because of all the dust. So anyway, that was all probably well worth it. And then I got to get married on a sand dune. So this will just show you how serious I am about sand dunes. And then you'll hear about it scientifically from me too from now on. Okay, so back to my presentation. Okay, so again, you should see wind on planetary surfaces. Let me know if this is not showing up. Thank you for the congratulations. So kind of what I want to have stand out here is that wind is a significant force on a planetary surface. It has an atmosphere. And there are a decent number of them that have atmospheres. You can kind of be thinking through which they are, and I'll talk about a number of them today. And what's really nice is that wind will kind of shape the landscape most recently. And so these recent landscapes reflect the action of the wind on the surface. And so what we like to do is study windy landscapes on Earth so that they can in turn kind of reveal conditions about other planets because we don't have a whole lot of weather stations on the surface. We mainly just have remote imaging from space, maybe a few landed spacecraft to be able to tell us what's going on. And then, of course, studies of other planets that are often in really extreme conditions compared to Earth can come back and help us understand the Earth better. And here I am getting some wind data from a really windy field day in Morocco. I remember it was so windy that it was actually kind of hurting my stomach because it was blowing so hard. I like to get out there in the middle of these things and really feel what's going on. So let's start at Mars. Probably for a lot of people here, Mars is their favorite planet. It's really amazing and a beautiful place, and in many ways can kind of feel like home to us. And so I can see why we feel that way. Here's a picture of Mars, and you can see a lot of the landscapes here. There's the North Polar ice cap that's both water ice and carbon dioxide ice. And oops, there we go. And then also you can see these three big volcanoes here, and then the largest one, Olympus Mons, that's the size of Washington and Oregon combined. And then the giant Valles Marineris. There's a lot going on Mars that makes it really exciting, but what's also exciting is that there are a whole bunch of sand dunes all across Mars. And this is because there is an atmosphere there. It's 96% carbon dioxide, where we've just got a couple percent of carbon dioxide in our atmosphere. And it's about 1/100th the pressure of Earth's at the surface. So it's very windy there, hundreds of miles an hour of wind, but they have a really nice kind of wind simulator at JPL. If you go, you can put your hand in the wind tunnel and it's 100 kilometers an hour and you think, oh, it's gonna really hit me. And it just feels like a gentle breeze. And so the density of the air matters a lot. And yet we still see forms that have been made by wind. So we know that the surface gets very windy. You can actually see in this atmosphere, the thin slice at the back here, that there's a lot of dust in the atmosphere. That's why all the pictures of Mars look red. It's because it's picked up the dust on the surface. And we know that global dust storms are common across Mars. Here's a picture separated just by a few months, and you just can't even see the surface anymore. Some of you might remember from the story The Martian, and especially in the book, it goes over this quite a lot, that this dust storm kind of drifts into view, and now all of a sudden the solar panels don't work. That actually played out in real life for the Opportunity rover. A dust storm lasted long enough that the solar panels couldn't charge, and we're kind of hoping maybe the winds would blow and clear the panels, but it never was able to wake up. So the dust storm is what ended the life and the mission of Opportunity. We see dust devils all across the surface. Here's a kind of time-lapse movie from, I believe, Spirit or Opportunity, watching some dust devils march across the surface. And that's pretty neat because that's the kind of really recent active thing that's going on Mars today, and we can see it happening. And we can, oops, it happened. Oh, sorry. Didn't need for that to happen. Can I close that? Here we go. I don't know what was going on. Keep that picture in mind for later. There we go. It's got a link in it. What is happening? Oh, probably a dust devil link. Okay, anyway, so then we can also see dust devil tracks across the surface. And one thing that stands out in this particular picture is there's a lot of dust covering everything in the landscape. You can see some faint outlines of craters right here, but they're covered up by dust. There's just so much of it because on Mars, there's just been impact after impact and the wind blowing across the surface for billions of years now. And that's sort of the main thing that's acted on the surface of Mars for billions of years. And then you see this cute little dark track winding across the surface from dust devils. I love this beautiful picture of the sand dunes on Mars. This is up by the North Polar ice cap. And the kind of image stretch that's used in the image emphasizes the ice here as kind of showing up as blue in this particular picture. And so you see the kind of ice below it, and then you see a whole bunch of dunes marching across that ice. And when we see sand dunes on Mars and on Earth and other planets, they are subparallel to each other. They're very regular in their spacing and their size. And so they're kind of aware of each other. And that's a really interesting aspect of sand dunes and ripples and other kinds of things that have to do with wind, is that the atmosphere is acting on all of the landscape at once. And so that helps to bring up a sort of self-organization that becomes apparent in their shapes compared to each other. And in the case of the Mars polar dunes, they exist because the glaciers move out and they carve up a bunch of material and then they recede back again. And so they produce a lot of sand from the landscape. And the same thing is true on the Earth. We actually have some really beautiful close-up pictures of dunes on Mars. This is from the Curiosity rover, and these are called Bagnall dunes. We were really glad that the go-ahead was given to, go up very close to the dunes, maybe take some samples. It's a little risky because you don't want to get stuck in sand when the main goal of the mission is to head up a mountain and classify what they see in those layers. But they did manage to pause long enough to kind of study these dunes. Notice they're dark in color. They're made of basalt, and that's just typical of the landscape of Mars. There is not quartz, and that's something to kind of think about, is that Earth is covered in sand on the seashores, and there are many seas of sand. We'll talk about a few of them. Most of the sand on Earth is made of quartz, and that's just the end product of plate recycling that happens on the Earth. By sort of changing the composition of the magma over and over and over again, you make it progressively more rich in silica and produce quartz. But we don't think that's a common process on other planets. And so we just don't get this leftover silica to make quartz. And if I were to pick up a handful of quartz sand on another planet, I'd be in complete shock. So we just don't think that process is happening. Instead, we know there's lots of volcanoes and lava flows and everything else, and that gets broken down over time into these sand dunes. Okay. The pictures of the sand dunes on Mars, I think, are so beautiful. This is a high-rise image. The high-rise camera you know, over the course of us speaking, you can picture a person kind of walking across this landscape. These are very high resolution images, and we're looking at dunes, and we're also looking at ripples on dunes. They're spaced by just a couple of centimeters. And the ripples change a little bit in character down here near the base, and they change to be a little more gravel rich, a little bigger particle size, bigger ripple size. Again, this is something we see in dunes on the Earth as well, where the wind accelerates and can pick up other things. And I love this one this is a high standing mesa. So the light is coming from the right and shining to the left here. And then you see a whole string of dunes that starts as one long dune and then breaks up into these little tiny dunes that are marching off downwind. So the wind is blowing from the left to the right. And there just are some very moving, beautiful pictures of dunes across Mars. Another feature that is important to me in my research and that I've been to a number of places to study is called a yardang. It's a little bit strange. We think it's a Turkmenish word. It maybe started their use in the Lop Nor. And these are wind-carved ridges. So notice that they're similar in some ways to dunes because they're regularly spaced and they seem to kind of know about each other. And yet we think of these as being destructional rather than constructional, which is what a sand dune is. So you have to actually move the sand together and form it up into a line, whereas yardang is just something that was probably once a smooth surface and then has been carved down into these linear ridges. And so we've removed material from this ridged area to create these regularly spaced features. We see these on Earth and Mars and Venus. And Venus is one I won't actually talk about today, but keep in mind that we do see sand dunes and yardangs on Venus and on Titan, which is a moon of Saturn. And so all of those have in common that they have atmospheres. And that's what's required to be able to carve away the landscape. So we've been to a number of places to study these. This picture on the right is a satellite image from China. And notice that they look like they're almost like ballistic forms. They're protruding upward into the wind, which is blowing from the north to the south in this image. And it almost leaves behind just a little kind of ballistic shock wave or something, although it's just a shape in gravels that are sitting out in front of this yardang, this wind-carved ridge. The tour guide that was with us said, "Jump and I'll take your picture." And I said, "That's not going to work. It never works." And she took the most perfect picture the first time. So I keep it. And what's very interesting is the tourism there is mainly Chinese nationals because it's way in the middle of the country. And the tourism is around the beauty of the features. And so they say this one is very special because it looks like the Sphinx. And then they'll find another one. This one looks like a phoenix, and this one. So it's kind of neat to see that through their eyes, that it's not the science that they're picking up on, but the beauty of the landscape. As Harold mentioned, I've been to Iran. I was really proud of this trip. My friend Laura Kerber and I planned this. And I'm actually not sure how she roped Justin into it, although I think it happened one day in a car ride. One or the other of them was listening to a Farsi tape, and the other one said, "Oh, are you learning Farsi? I want to go to Iran." And the other one said, "Well, I do too." And so anyway, just sort of was a long-term quest of theirs to be able to go here. And I sort of was pushing. I said, "We've got to do this in 2016. You never know what will happen in November, if things will change. You know, over the course of my lifetime, it's not been possible to go there." And so for there to be a brief respite, I was looking for those places. Where is it good now? And where it could not be good later, and try to go to those places. And so we specifically searched out this area. And I will say that it was it was easy. Once the visas came, and you have to go through Pakistan embassy to be able to go there. Once the visas came, we were very carefully looked after the entire time. And I think that's part of it, is the country just wanted to know where we were every second. And we felt very safe, and we had probably the best tour guide I've ever had in my life there. She was really excellent and showed us a lot of great things. The main reason for us going is to look at this giant area right here. You can see those very thin, narrow stripes. These are carved into clays from an old lake bed. And it's a huge field. It's over 100 kilometers long, and it's right next to a field of sand dunes. And so I'm going to zoom into better satellite images of both the yardangs and the sand dunes to show you the difference here. And here you can see they really do look quite different from each other. The yardangs are very straight. And in this case, I really love the mosaic pattern of this particular yardang field. This is different from the Chinese ones, right? Those were more spaced out and probably older or more mature. This is just kind of in the process of being created, I feel like. And it's just starting to carve out these corridors. You can actually take a journey all the way through here. You start over here and you kind of make your way zigzagging through here. Laura and I are dying to do this. It takes a good month though, so we got to find that time. And we had that time sitting out in front of us over the past, 8 months. And, but we just can't go anywhere. Sort of like this tragedy of our time right now is that we have the time, but not the means. So, and then here in comparison are some sand dunes. And notice again, they have this reddish color because it's quartz sand covered in iron oxide. And that's what makes the sand, just like most places on the earth. And they kind of meander a little bit more because the wind is blowing and changing them. What do they look like up close? Well, here's a little film that was made by our driver, MJ. Here he is right down here. This is from a drone. Here's Laura up here, Justin, Harold's son, and me. And look how big they are. These are these giant towers of clay, and they form by not only wind carving them, but they also sort of just collapse over time because they're so big. And there's one ridge right here where we're standing, like the tense music around it. I love that. And then another set of them in the background. So it just is hard to get your mind wrapped around the scale of them. They're very large. Here's some features near the ground that look a little more wind streaked. And yeah, the things near the ground are more wind streaked. The ones up higher are just sort of like towers. And so we spent a good few days exploring around in this area and trying to understand these features a little better. Oops, I need to skip to this. There we go. Their shapes are kind of like the ones we saw in China. They look like there's something flowing past them, right? This one looks like a submarine to me. And the wind is coming from the right and blowing to the left. And while the mountain is fixed in place and the wind is blowing around it, you could as easily picture it plowing its way toward the right. And so it's interesting to see the similarities in form in these features. Here's Laura right here. She's sitting on the edge of one of them. So you can tell they're made of clay. They're all kind of pitted and rugged from whatever rainfall happens there. And then you can see them just sort of dotted across the landscape off into the distance. They do line up very neatly into ridges, but it's just hard to see that from this view. Laura and I, and Justin, all three of us really grabbed onto the idea of the culture while we were there. There were some pretty strict requirements for our dress the whole time. And we just kind of tried to enjoy it and appreciate what we were experiencing. And we sort of had fun with photo shoots out in the desert. So it was really great. It was a fantastic experience. Here's a picture of some of the yardangs taken at dawn, and the light on them is just really beautiful. And notice there's some other tourists who also found them. We did some adventuring while we were there. It was very hot, and for some reason I sent the truck off in the other direction, and then the three of us walked up and around and meandered and then met the truck a little bit later just to get a sense of what this whole sort of line of yardangs was like, and we really enjoyed that. And I had with me my Persian field rug, and we made good use of it, laid on it a number of times. So here we are taking a rest. That's Justin Haroldson. And it was just really fun. With the three of us were perfect travel companions. We got along very well and had this kind of same goals in mind. And so hopefully we can go again to somewhere really fun. One thing that we notice about yardangs is that there is also a lot of gravel in the corridors in between the yardangs. Every yardang field I've been to has gravel. And the gravel is organized up into these ripples. And some of the ripples are spaced by maybe a meter from each other. Look how beautiful that is. There's this coarse gravel leading up to sort of finer sand on the backside of it, and then coarse gravel again, and then finer sand. And so we kind of picture that there must be strong enough winds to blow to be able to move these gravels around. And it's not necessarily that they can pick the gravel up, but just that they can roll and slide across the landscape and form up into these big ripples. And we think that they must have an important role in the formation of the yardangs. Maybe they protect them initially and then help to carve them subsequently. And maybe otherwise the clay would just disappear and would never form into a yardang. We're still puzzling through that and not quite sure what the role is yet. And here's a close-up of these gravels. They're always about the same size wherever I've visited them in the world. Okay, we'll jump way across the world to another desert. This is a high, cold desert. We're at about 10,000 feet here. And this is in the Puna of Argentina. So we're way up high on the Altiplano behind the Andes Mountains. And these particular yardangs are so beautiful. They're white in color. There's absolutely no water here. Maybe there is occasional frost sitting on the backs of them that help to alter the color and change that into some clays during the winter months. But for the most part, there is very little rain or snow that ever falls here. Notice some gravels in the corridors again. These are really beautiful because they're carved into volcanic ash. And it's a little more rigid than the clays in the Lut Desert. When we walk up on the clays, they'll slide backward a little bit. These are utterly rigid, and we can scale the sides of these and crawl right up onto the tops. There are big cracks that have formed in the ash flow, probably as it formed, as it was cooling. And the cracks help. So here's maybe a former crack sitting within the yardang. It helps the yardangs to form because they topple over and then break apart. And then notice again, the gravels all around there. It's really fun to be in them and to wander through them. And we pick these little paths. And once again, we have the cars drop us off and then tell them to pick us up. And they're always calling us, "You're 3 hours late." "Yeah, sorry." So we just get caught up in enjoying where we are and enjoying where we're being. You can see right here, there's a whole bunch of holes. These are holes where there was pumice. There's a layer of pumice that's this really light material that forms in volcanic ash. It's the same stuff you get to rub off your calluses, just really light and filled with air. And there are layers of that contained within the yardangs. Here's a student of mine from Brigham Young University, Jonathan, and he's measuring each of these forms right here. They're called dedos, which is Spanish for finger. And there's a kind of a solid rock that's contained in that ash. And then the rest of the ash is a little softer. And so as the wind is blowing across these, it leaves the rigid material out in the front and then creates sort of a finger out behind it. Eventually this will break and the dedos will tumble down. But what's great about it is it's a wind indicator. And so Jonathan measured out all of these dedos to be able to tell us what way the winds are blowing. And here's a bunch more of those dedos sitting right here. And then we also had with us Jason from JPL Rabinovich, and he's helping to put together a fluid dynamics model over the yardangs. And so we let off some smoke bombs and watched the smoke kind of travel around the yardangs and made those measurements of the dedos and these other kind of windswept features. And he's putting that information into his CFD model to be able to show us what is the wind pattern across these yardangs. He says he's got something like 4 million data points so far. So we're still working on kind of putting all of that together into a model. We do have initial results, and you can see that in the lower corner right here. What I think is cool is that there's this really interesting recycling pattern. And we actually see that in the dados. There's these weird kind of like upwind pointing dados on the back sides of the yardangs. And it's consistent with our initial wind models right here. And so it's neat to see the two of them come together. This is my graduate student, Dylan, and he's working on testing the rock hardness because the hardness seems to affect how large the yardangs can grow. And so the neat thing about that is, well, we can actually look at how big the yardangs are on the Earth, and then we can measure them on Mars from remote sensing. And then we actually understand how the hardness affects the size on the Earth. We make the conversions for the gravity and the atmosphere of Mars, and we can maybe make predictions about the composition and the rock hardness on Mars, even if we can't land something there for many years to come. Okay, here's another little movie. This is a kite camera. So occasionally it's too windy for a drone and you want to just put up a camera anyway. So we have a GoPro mounted on the bottom of a kite. And you can see as you get up higher that these are also regularly spaced into not only lines, but knobs. And it's a really beautiful landscape. It stretches out to great distances here. It's really a hyper-arid desert. You don't see any vegetation here at all. And it's just because it's way too high and too dry. And it's hard enough for us to make it as we're studying them during this time. This is again Laura. So Laura and I are really on this campaign to understand yardangs better. And then my students, here's the gravels again. The gravels are everywhere. They look the same as they did in the Loot Desert. Here's Jonathan puzzling through a couple of different wind directions that might have made those gravels and the gravel ridges. And then they are actually just really beautiful because we already have the white ignimbrite. And then when you put these dark kind of limestone, they're from the mountains far away, limestone gravels on the top of it, they just make amazing, beautiful patterns. And it's one of my favorite landscapes on the earth. Well, I mean, everything looks really calm. How do those gravels move around? Occasionally the wind does blow. So here's a big dust devil. So we saw that in action, just like the ones we saw on Mars. Then we actually got a really big windstorm kick in one day and just sandblasted us. I mean, I thought, okay, the sand does get all the way up high onto the tops of those yardangs. Now I can see it. We're always, again, we're kind of happy when the wind blows because then we can see the process in action. And then when it's not blowing, we can put the drones up. And so Laura and I have been working with our drones lately. And here's a video across some very unique landscape. They're not separated out yet into specific yardangs. We think it's sort of like proto-yardang landscape, like it's kind of underway. They're starting to form. They just haven't deepened on the sides yet. But to me, it looks a lot like wind sculpted ice or snow that we see in other landscapes on the earth. Keep doing that. Again, more fun with the photo shoots. I tried to look like I was Rey from Star Wars. So that's the outfit I was going for here. And then of course, like it's really beautiful as we descend down out of the plateau. This is a vicuña, and it's a sort of alpaca-like animal. There's also alpacas up here and llamas, but vicuñas are really common, and they're beautiful, kind of undulating as they run across the landscape. And you can buy some neat vicuña fur materials and sweaters. And I talk a lot about my tour guides. They're just, I really can't state strongly enough how important it is to get a good tour guide. And once you find someone who's good and they know that you take care of them, they will take care of you. And so they're willing to work really hard for us. And they're patient with me when I say, hey, I need to go to this spot right here on this image. And they say, that's impossible. I'm like, okay, what about this little path over here? Okay, we'll try. And they're really good to work with us and get us to these places we need to go. So we go back to them again and again every year. And we had plans to go back, kind of one last time for this particular field campaign this December. But of course, everything is on hold. So we're really crossing our fingers for December 2021, especially to get back and help them. I mean, their whole livelihood is dependent on tourism, and it's so rough that all of that is halted for everybody worldwide right now. Okay, let's jump over to Titan, beautiful moon of Saturn. It is the largest satellite of Saturn and is one of the largest satellites in the solar system. Only Ganymede is larger than Titan. And both Ganymede and Titan are larger than the planet Mercury. So it's really quite big across and has this thick, hazy atmosphere. The atmosphere, it turns out, is really similar to Earth's. It is, we don't have the composition written on here, but it's mostly nitrogen, just like Earth. It's got the second highest surface pressure of all solid bodies with atmospheres, which is the first highest surface pressure. Anybody can think of that. Turns out it's actually Venus, right? Venus has got a very dense atmosphere, and Titan is second behind Venus. Earth is not even as dense as Titan, but it's very close. It's 1.5 times the pressure at Earth's surface and 4 times the density. This means that the atmospheric conditions on the surface of Titan are very similar to those on Earth. And I believe that has led to very similar landscapes as well. We know that there are rivers and lakes. Here's a giant lake on the surface of Titan. And this is actually, because of its location in the solar system, 10 times as far away from the sun as the Earth, this is a lake of methane. And so imagine if you're standing on the shores here of this lake, you're standing on sedimentary rocks, maybe of organics. The organics are made high up in the atmosphere by breakup of methane, and then they settle down to the surface as solids, and they make up sedimentary layers of organics. You can kind of have anything you want. We don't really know exactly what it is: benzene, propane, acetylene, all in frozen form. And then that covers a bedrock, a basement rock of water ice. And that's what makes up the mountains and the crystalline basement of Titan. It's a really odd landscape, different for us. And what we see at the surface all across the equator, everywhere you see this brown material, is seas of sand. And we never would have expected sand dunes. I mean, there's an atmosphere, sure, and we know there was a lot of methane in the atmosphere that could be in liquid form. So kind of thought there just would be oceans of methane on the surface of Titan. But instead, they're just these isolated lakes and seas up at the polar regions. And the rest of the surface is a dry desert filled with sand. And that's been really exciting and fun to observe. And the dunes on Titan here, shown here in this radar picture, radar is a little different from visible images. So everything that's dark is kind of smooth or indicates fine particles. And so the dunes here, just like on Earth, show up as dark. And they're parallel to each other, they're long and straight. And again, those particles were created up in the atmosphere, they settled to the surface. Maybe they were eroded by methane rainfall, eroding the bedrock into different sizes, and then shaped into dunes by wind or some other means. We're not exactly sure what the sand exactly is made of yet. Here's a really beautiful picture showing the dunes and then the underlying bedrock. Here, these little mountains are kind of poking up. And notice when the mountains poke up, the dunes get halted. They butt right up against it, and then they kind of continue downwind eventually. So the wind is generally blowing from the left to the right here. And sand is being transported down the dunes from the left to the right. And that on Titan is always from the west to the east. This happens kind of during storm winds, during season change. The winds blow very fast down near the surface and transport the sand. The dunes look very similar to the dunes in Earth's big deserts. They're the same kind of dune. I didn't even know about this kind of dune before because we don't have them in North America, but they have them all across the Sahara and Arabia and in Asia. And it's called a linear dune. They're about a kilometer wide, spaced by a kilometer or two. So that's really big. It takes a while to get up and over them. And then the wind is, again, blowing from the left to the right. Here you can see those little wispy pieces of sand coming off of the tops of the mountains as the dunes come up to the summit. And that looks very similar to radar pictures of sand dunes on Titan. The dunes actually collect up into giant seas of sand. And that's a term that was used when people first realized exactly the magnitude of sand that's contained in the Sahara Desert. It's a sea of sand. And so we're kind of trying to figure out, why is the sand stored in these areas? What is special about these regions? Why, for example, didn't it collect more over here on the left? What is it that halted that collection? Why is it more comfortable here on the right? How much sand is stored here, and how long does it reside here before it's carried out and moved somewhere else? And so we're kind of investigating lots of properties of the dunes, how wide they are, how widely spaced. What is the topography like underneath the sand dunes? And that kind of data is a little bit sparse from Cassini. But we're learning more and more all the time through our studies. And then we do comparisons with dunes on Earth. So here is Namibia, the Namib Sand Sea. This is Southwest Africa. And notice that there is a huge volume of sand right here. It's confined by the Khoisan River up in the north right here, kind of helps to stop the sand movement from going too far north. And then other rivers here are kind of entering in and slicing through the dunes. Here's an Aster digital elevation model. So it's kind of like a false elevation showing just how thick the sand is when it's in sand dune form. So out here's the coast, and then it ramps up to these big, thick, maybe tens to hundreds of meters in thickness of sand. And it all comes from the Orange River out of South Africa. So one day we decided to drag a ground penetrating radar instrument up and over the top of one of the dunes. And it did take all day, because remember how big I said they were. And of course, I've got students that are helping. I think I'm actually pushing this time, but normally I've got the students to do the pushing. But what did we do all this work for? Well, then we get a picture down through the subsurface, and this is up to about 10 meters thickness. And you see all these stripes. Those are kind of individual layers that are showing up as reflections back to the radar instrument. And you can see a sort of gentle, straight collection of layers at the very surface, but then down below that, there's a lot of swoopiness, some angles. There are terms we use in sedimentology, cross bedding, trough cross stratification, all that means that the sand is moving up and down the dune long axis. And we sort of helped confirm that with this ground penetrating radar study. Okay, well, something that's really exciting about Titan that's going to happen in the next decade is the Dragonfly mission. And this is exactly what's going to happen. It actually directly descends into the atmosphere of Titan. It gets dropped out of its descent shell and fires up. And it's 4 sets of 2 blades, so 16 total rotors, blades actually across the surface of the spacecraft. And it lands in between the sand dunes. It opens up its own antenna, talks directly to Earth. It's got a radioactive battery in the back to help power it for a number of years. And then it can pick up itself and fly again across the surface. It's really exciting. And it will bring a number of instruments to be able to study the materials. It will actually suck materials up into the body of the instrument and use a mass spectrometer to tell the composition of the sand. And that to me is the biggest prize of all. So we just get this handful of sand from the surface of Titan. And then we understand that's kind of the end process of all the organic processes on the surface of Titan. And it has produced these large mountains of sand. What is that made of? And it can also get a sense of the bedrock. We'll be able to drill into the bedrock that it's sitting on and analyze that as well. It's actually a pretty big spacecraft. If I stretch my arms out completely, it's a little bit more than me wide. And it's about me tall. And so it's a really big, it's even kind of called a rotorcraft lander rather than focusing on the drone capabilities. It will spend most of the time on the ground, but then be able to pick up and move great distances. And it's pretty revolutionary because we've so far just had landers and orbiters and then rovers that can go, tens of kilometers over their lifetimes, which is really good. But this will go hundreds of kilometers over its lifetime and view vastly different regions across the surface of Titan. So it's going to be revolutionary and really, really exciting. It launches in 2034. No, it launches in 2026 and arrives in 2034. So we have a little ways to go, but we're patient. Here's a picture of it. And you can actually go to this website right here and see those animations and see more things on the website. Okay, one last body. We're going to go all the way out to Pluto. And can you believe that we have this image? Prior to 2015, all we had were just really fuzzy, images of the surface of Pluto from the Hubble Space Telescope. And that was going to be the best we could do until we sent a spacecraft there. And some very persistent people, Alan Stern in particular, just did not give up and got his spacecraft to go. And I mean, absolutely, it was worth going there because the surface is unlike anything we ever would have predicted. It's got this giant heart-shaped glacier on the surface. A glacier is nitrogen because at 30 times as far away from the sun as the Earth, Pluto is 30 degrees above absolute zero. And so the atmosphere, of Titan, of Earth, that's nitrogen, collapses down onto the surface and forms a glacier way out of Pluto. And so that has just led to all kinds of very interesting and exotic geology that happens on the surface. Here's a picture of that beautiful glacier right here. I think this is one of the most beautiful pictures in planetary because it kind of looks like Earth, doesn't it? It just reminds you of home. There's like, oh, hey, there are mountains and there's a glacier and there's an atmosphere. It looks like Earth, but they're utterly different materials. They're water ice mountains. It's a nitrogen glacier. It's a carbon dioxide atmosphere with layers of haze, and yet it reminds us of home. And I think that's really compelling. There's also cryovolcanism, we're pretty sure. And then the thing that I find really interesting, there's a lot of wind and sun dominated terrains. And one really exciting feature that actually a friend of mine discovered on Facebook, we were looking at this picture that somebody had posted and we were joking about, oh gosh, yeah, look at all these sand dunes on the surface. And he wrote me privately, he's like, yeah, I mean, they're sand dunes. And I said, yes, of course they're sand dunes. And so he said, well, let's work on them. And I said, I'm sure somebody else is working on them. So I wrote to the team and I said, hey, we're just wondering if anybody wants any help working on the sand dunes. And they said, what sand dunes? We haven't seen any. And so they kind of gave us the green light to go ahead and present our evidence to them. They would either come onto the paper or just let us do our own thing. And they ended up coming on, a lot of them, and we all shared in this discovery. And they, of course, produced a lot of other data that was really helpful to us. But I think the reason that the two of us thought that is that I try to go out to visit sand dunes as much as I can on the Earth. And so here's this giant mountain range right here, and then this neat row of regularly spaced linear features, not quite as linear as Yardangs, right? But they kind of meander around more like dunes or ripples. And it just reminded me a lot of Death Valley, California. And I go there every year with my students. Here's Claire sitting on the top of a dune, and you can see dune after dune right at the base of a mountain, just where dunes should form as winds are either rushing down the mountain or they've kind of been diverted at the base there, and sand collects in that location. So we were prepared to be able to see them and understand what was going on. And the spacing and the sort of splitting that happens reminds us of dunes that we see from satellite images in the Taklamakan of China. And so we put out a paper about that. And the question is, I mean, how are they even here? You know, does Pluto have an atmosphere? And then what could they possibly be made of? We started with the geomorphology. We started with the shape of the landscape. Hey, there are sand dunes. So now someone needs to explain, where's the atmosphere and is it strong enough? Right now, the atmosphere is a little too thin, but even just hundreds of years in the past, it was thicker because of the very bizarre orbit of Pluto, which is tilted 120 degrees on its side, and therefore it receives really long summers and then really long winters, and so it gets inflation, deflation of the atmosphere over time. And so that could help explain how the wind could blow in the past to form the dunes. And then somebody else came forward and said, oh yeah, we've got some pretty strong methane ice signatures in that region. And methane ice at that temperature is really rigid. It should make a nice brittle sand. So we think of it as holding a handful of methane sand in our hands. And that's just, again, even more bizarre. Like, how could it get more bizarre than this? So it's been really exciting to look at these regions and be able to identify landscapes that look familiar to us. And so this is kind of all I have. Wind-dominated landscapes are really important, and they can actually make a lot of features if they have enough materials and surface fluids, mostly wind. They can be an important proportion of the surface. They're very important across Mars and Titan, almost more important than Earth when you consider that our surface is dominated by that giant ocean. And the features that we see often highlight the most recent processes. So it's good to keep our eyes on that and say, oh, well, the wind was blowing in this direction most recently. And then, of course, we continue to study these analog landscapes on Earth that help reveal important aspects of other planets. And then the other planets can do the same for Earth as well. And that is all I have. So I think I will stop share and see if there are any questions from anybody, or you can decide what your time is like.
Yeah, thanks, Janie. That was great. That was really great.
Thank you.
So are there any questions?
Janie, I have a question. Just this morning, I was listening to a podcast that was talking about the problems of dust on the moon and how it's so electrostatic. They're trying to find ways of zapping it with things like an electron gun to make it, because it's so sharp and it hasn't suffered the erosional forces. You talked a little bit about the gravel in Iran, but I was thinking about dust on the moon, on Mars, and dust such as it would be on Titan and other planets. Is the wind essential in making the dust a little more round or eroded than we would find it on the moon?
Yeah, actually, that's a really good point. I hadn't thought about that before, but I think that is important. Like, a lot of the dust that's created on the moon is just made by churning by impacts. And so they'll just eject it up in the atmosphere or up into the bare sky, and then it falls directly back down again. And so it's a lot of times just glass shards. And those glass shards don't have any way of being sort of rounded or broken apart into even finer material and deposited or layered or anything like that. And so, so that's true. The moon's dust is unique in that it's shards of glass and it gets into everything. There were real problems with the Apollo astronauts and that dust. And not only did it stick to the suits, but then once they got it into the spacecraft, it would get, you know, under their fingernails and create a lot of problems for them. And so for long-term lunar habitation, we're going to have to think about that and about how to deal with the dust. And similarly for Mars, so the wind has blown things around a little bit on Mars, but it turns out the composition of the dust is toxic to people. It's made of chlorides and other things like that, perchlorates. And those turn out not to be very good for us. And so that's something else to try to mitigate against, is you don't want to bring a lot of that dust into the habitats and try to keep it out there on the suits where it's better. I think we don't really know much about the dust of Titan. Of course, we're not quite yet thinking about inhabiting Titan, but in many ways it's a great location because the pressure of the atmosphere means you don't need a pressure suit, and that's a major deal. You do need, of course, plenty of like insulation, but pressure suits make everything difficult. So I guess maybe, you know, again, we're just lucky we live on Earth because everything works in our favor to help us, and the action of water, especially, that sort of eats away at the sharp edges, and the wind bouncing things around just make it much more friendly.
Other questions?
Yes, I have one. Right around the time when you're talking about the ground penetrating radar, I thought it ironic because I was sitting here thinking about, has anybody with the smaller thickness sand dunes, have they done almost like an ice core kind of measurement, you know, where they dig down and see and try to age, you know, get a calculation of the age of the dune?
Yes, actually, I forgot to mention that. That's another thing we're doing is we do drill down and we grab a sample and bring it up. And we use age dating called optically stimulated luminescence. And what that means is that it essentially tells you the last time it was exposed to sunlight. And there's these dislocations that form in the quartz grains, and they sort of get reset by the cosmic rays. So if you bury it, then that can decay over time. What we found, it's really hard. I haven't figured out a good method. I know somebody else took a whole truck out and a drill and did it that way. But when I just bring a hand auger, the best I can do is sort of like 2/3 of a meter, and then the whole pit collapses around me.
Right.
The best thing would be to fill it with water and then try to dig down and get the sample. But I can usually get down in the space between the dunes, the interdune, and get that age. And it's different material there. It's kind of like a soil typically. So all of the dune surfaces, even the very oldest ones I've aimed for, have been basically modern, but I've gotten some pretty old interdunes. So in Namibia, that interdune is 44,000 years old. So that's kind of neat that, you know, that's the last time that space was exposed.
Nice, thank you.
Thanks.
In our chat, Jerry Marin asks, are there any electrostatic effects of the sand particles rubbing against each other when wind moves sand in a dune?
There can be in some areas. It can work especially well on clays because clays kind of respond to that electrostatic charging. I think the silica sand-sized particles don't as much. They get overwhelmed by the action of the wind. There was some discussion about how the organic particles, which might sort of be like plastics, could charge each other up on Titan. But the reason I kind of think that might not be happening is that or to, you know, a really great extent, is that with the clay dunes that end up having those effects, you can kind of tell that they look like they're anchored in place a little bit more. They are stunted in their growth and in their progression across the landscape. And Titan's dunes look exactly like the silica sand version of dunes on the Earth. And so that leads me to believe that the particles are round and hard and are mainly dominated by the wind action on them. But we definitely are going to look for evidence of that electrostatic charging happening on them. And that, as Harold mentioned, is really important for the dust grains on the moon.
Yeah. Hey, this is Lewis Berman. I have a question. What's next in wind on other planets? I mean, are there other observatories going up? Are there special observing programs you're doing, or what are you guys trying to answer, and what tools are you applying to those?
Yeah, I think there are still a fair number of questions about, especially about those really large dunes in the Sahara and Arabian deserts. How old are they? And how, because again, even with the dating techniques, it's hard to get to the very base of those really large dunes. We haven't done that quite yet. What were the conditions under which they formed? Are they still forming, or did we have to have a really windy kind of Pleistocene in the past? And it's the feeling of some of us that they actually are not forming now, that they're kind of relict forms, and that we needed to have very windy conditions before. But as we look at the dunes on Titan, those look to us in general to be pretty young and active. There's nothing cutting across them or eroding them the way we see the dunes being eroded on the Earth. And so that might suggest that the conditions on Titan are correct for the formation of that kind of dune. And so Dragonfly is going to help answer a lot of that in saying, okay, yeah, these are active. We can tell because we're up close. And these are the conditions required for them to form. And now we can kind of back that out to conditions that may have existed on Earth that we weren't as aware of before. We have a general sense of paleoclimate, but this would tell us in a little more detail what that paleoclimate is like. And so I think building out that understanding of climate change over time on Earth by using these other planets who might have conditions today that are like what they were on Earth before is, I think, going to be really valuable. That helps to tell us about sort of desertification and change in especially those vulnerable areas. I find that to be really important. I think what's also important is that we're pushing the boundaries of what's required to form wind landscapes. And so first by looking at Pluto, and another thing that gave us the bravery to look at the dunes on Pluto and call them dunes is that we had seen something on a comet that to me was a dune. And there was no question, the shape of it was a dune, but comets are airless. And so how in the world would that happen? And that got everybody thinking more carefully about, well, you could angle some jets across the landscape of a comet and that jet might end up forming a dune. And so before we just go and say, if it's airless, there's no wind on the surface, we ought to look carefully at, well, maybe some conditions could exist that allow that to happen. And I think on the moon, that's also going to be true. Are there places where jets have escaped out of the moon, or even volcanic eruptions that might have caused wind-carved landscapes? And we'll probably see those in the future.
Cool. Well, thank you.
Yeah.
Hi,
How
this
are
is
you-
Isaias.
Go ahead. Go ahead, Isaias.
Yeah. So, Johnny, this was a wonderful talk, by the way. I love the pictures, and I think you must have a very popular course with students really competing to go to those wonderful trips with you.
Yeah.
The question I have is for those of us who are not in the academia within those fields, trying to understand what makes you decide to send like that mission to Titan as opposed to somewhere else. It's going to take 8 years to get there. It's going to take a lot of time to get the data and get the answers. So, and I'm sure it's going to be pretty expensive. So why go there as opposed to somewhere where there is water, for instance, in some of the moons of Jupiter as opposed to Titan?
Yeah, what I did not emphasize here is the main purpose of the mission, and that is actually to look at the organics of Titan. And so it turns out that Titan is really special in terms of its potential for life. When we look at somewhere like Europa or other ocean worlds, and Titan is also an ocean world, this just means that there's liquid water beneath an icy crust. There is the potential for life to have started at Europa, but we don't see a surface that's conducive to life. You have to go deep underneath that icy crust into the ocean to be able to look for an environment that is right for life on Europa. And you may even need to go all the way to the bottom of the ocean floor where there are seafloor smokers, and that could be tens of kilometers deep. And just kind of think about that in terms of our own ocean. We're just 5 kilometers deep. Now you want to go tens, at least, of kilometers deep at Europa. And so that's a very kind of different environment than we're used to, and very high pressure, very cold, very dark. But on Titan, what we have is liquid methane on the surface. We have a water ice crust. And so if you have an impact event, that will melt that water ice crust. And now you've got liquid water mixing with methane and then this endless supply of organics that have formed on the surface because of the recombination of methane into longer chain organics. And specifically, we've measured with Cassini propane, benzene, acetylene, and other long chain organics. So we know that those are there. And so in reality, the accessibility of finding that environment that might have been right for life to start is much easier on Titan than anywhere else. So the main thrust of the mission is to go and look at those environments in the dune regions, because that's where most of the organics are collecting, and look for areas where the chemistry might have progressed to the point where life could have started. And that was the most compelling argument in favor of Dragonfly.
Makes sense. Thank you.
Thank you.
Janie, it's nail biting to listen to them landing on Mars because of the 14-minute delay. And when New Horizons went to Pluto, it took hours to know whether it had actually flown by the planet or not. How are you going to navigate a flying object on Titan as far away as it will be?
Yeah, exactly. The time delay is, I believe, an hour and a half out at Saturn. And so, yeah, you absolutely have to have autonomy in the spacecraft. One strategy that we'll use is that, the spacecraft will come and land, and it's maybe that first landing that is the most kind of nail biting, because hopefully what we can do is hover for a while and wait for everybody to say, yeah, okay, that looks okay, go ahead and land. And then in the future, what it will do is pick up and kind of fly over a region that it will have imaged on the way down. Let's fly over here and then come and land in the safe spot again, analyze all of that imagery and find the best landing spot to go to next, and do this sort of leapfrog strategy by, before hitting the next landing spot, you go scout the future landing spot and then land, and build in a lot more time for the team to be able to analyze where is the safest to land.
You mentioned that the spacecraft itself was going to transmit its data by itself all the way back to Earth?
Yeah, isn't that amazing?
Yeah, that'll take a while.
If you add an orbiter, suddenly it's out of the cost of the New Frontiers program. And so we couldn't put the orbiter in. So that will limit the amount of data that can come back. You'll have to kind of high grade the data, the images and everything to be able to send it back.
Mm-hmm.
So the communication will be direct from the lander to Earth, not going through an orbiter?
That's right. Yeah, it's got a little...
Yeah, I was shaking my head at that one, yeah.
Yes. That's really going to limit the data rate.
It will. Right. And that's another reason we're landing at the equator, is we want to have it pointed as direct to Earth as possible. So we actually can't go up to the lakes, which are up at the polar regions.
Mm-hmm.
But we might find other liquids on the surface. I'm pretty confident that, I don't know. I'm assuming that we will. I don't want to say I'm confident that we will.
Isaias mentioned the pictures. I was absolutely fascinated with the pictures of Iran and the high desert of Argentina. I was wondering, did you have a professional photographer along, or were these just photos taken by, what kind of cameras you were using? And
yeah, most are mine that I show in these talks, except the ones of me. But sometimes I'll pose them and then get somebody to take it. But I typically use a Panasonic Lumix, and so handheld,
right.
You notice that the videos were tall and skinny, so we can get out our cell phones when it's really windy. My cameras kind of get destroyed. I've gone through a lot of cameras, but the cell phones are getting better and better. I'm always surprised.
They're fabulous pictures, yeah.
But yeah, Laura's got a good talent for it, and I'm getting better and better. Sometimes I try to find a student who's a good photographer, because I can teach them the other things, but it can be hard to learn the photography. So.
Anybody else with a question? I don't see anything in the chat. Speak up. Anybody?
I have one. How high will Dragonfly be able to fly up?
This is known, and I'm not sure I know it. It might be on the website. The atmosphere is really thick and extended. So, it will be tens of kilometers at least. the topography is really pretty subdued across Titan, and so there's not the need to go really way high up to avoid mountain ranges or anything like that.
I was just wondering if you could go up and look at the higher elevations on mountains and such.
We'll be able to
just
get
to see.
high up above the landscape as any of the tallest mountains. We'll be able to get up above those.
Oh, that's great. Okay, good. Good, thank
Yeah,
you.
and I think we probably will go up in the atmosphere a bit to get a sense of the atmospheric composition and structure and profile and everything. So we may do that a number of times.
That's fantastic.
Okay, anything else?
I think
There's a soundtrack you can still download of the Huygens probe landing on Titan. And I just have to say, every once in a while I listen to that and go, these are winds blowing on the moon of another planet. And it is
Yeah.
just absolutely mind-blowing to think that we've actually recorded something like that. So this is a very exciting mission you're working on.
Yeah, oh, it'll be so exciting. You're right, I should go find that and put this in this talk. It's a good idea.
Yeah. Well, I'm delighted you could join us.
Thank you so much.
You're welcome to stay with us while we talk about the more mundane aspects of the club. I understand it's a few hours earlier where you are, and as with Laura, it's near dinner time for you.
Yeah, ready to go.
But I really, really appreciate you joining us. It was fascinating, and I really enjoyed hearing you speak about your explorations and our plans for Titan. That's great. Thank you so much,
I
Jeannie.
appreciate it, and good luck to everyone. Thanks for taking your time.
Oh, thanks.
Thanks.
Thank you.
Thank you.
Anybody else with anything for the good of the order? Anybody have a cure for clouds? That's what we're looking for.
A big enough laser will do it.
Yeah, what we need is a really big green laser.
Lou,
Yeah, I don't. Yeah, we're all for legal lasers. So
Yes.
legal.
That rules out the lightsabers. Well, I know Janet wants to talk a little bit about the auction. I actually have to jump off again. I am supposed to head down to Barnegat Light for a week tomorrow, and I haven't even started to pack. So I've got stuff to do. Otherwise, I would be hanging with you guys. So Jeremy, let's toss it to Janet. I'm going to bail. I'll see you guys in October if I don't see you out on a clear night between now and next time. So take care. Thanks very much.
All right.
Thank you.
have fun, Harold.
All right. I think we'll shut off the YouTube.
Yep.